Hey everybody, this is Larry. Hit the like button, hit the subscribe button. Let me know how you're doing this problem. I'm going to solve it live right about now. 92, reverse linked list 2. We reverse a linked list from position M to N. Do it in one pass. 1 is less than or you go to M, which is less than or you go to N, or which is less than you go to the length of the list. What is M and N? Oh, so not the entire linked list, just the position M to N. So this is a position though. For some reason, the numbers are the same, so it's kind of unfortunate. Okay, so basically, I would just it's kind of tricky. And it's one of those things that I just have to think about. There's a lot of weird edge cases, and the way that I would attack this problem is just recursion, or yeah, well, it's either recursion or a stack is what I was going to say, and they're both the same. It's just whether you want to do them implicitly or explicitly. I think I'm going to do it with a stack so that this time, just so that yeah, we can kind of visualize it together. Let's put together. Let's go. Yeah. So now let's have a node is equal to, let's go to current node is equal to head. And then while current node dot value is not M, so we want to get to the beginning of when do we want to do this. We do current node is equal to current node dot next. Yeah. And this part is the part where you can, in theory, do recursively, but I'm using an explicit stack. So now, while current node dot value is not equal to N, let's just put it in the stack. So stack dot append current node. Maybe I'd have to ordered incorrectly, but I think it's roughly the same. No, that okay. So if this starts, to be clear, this starts at current node is equal to M, and then it ends at current node is equal to N, but it does not append it. So we actually kind of want to do while loop, which we would do it manually by just copy and pasting this part. And then now we can actually do this for here. So now we have the stack that contains all the nodes that we have to reverse. So then now what do we want to do? Well, we want to go reverse, right? So let's just do that. I think I'm missing one thing here, is that after we reverse the sub linked list, we have to set the pointers from the beginning again. So yeah, so we might have to play around this a little bit. I mean, there are a couple of ways to do it cleanly. I'm going to just write it more procedurally, so that it's a little bit maybe easier to read, but we'll play around that. But let's reverse the linked list first. Reverse the sub list. And now let's just go from for node in the stack, reverse of the stack, basically from the top of the stack, and we pop them one by one. This is just a very syntaxy thing of writing it kind of. But now node dot. Maybe I should just reverse the stack. Okay, fine. And it's just slightly easier to understand. So yeah, so let's actually keep track of the previous node. Yeah, let's do that together. Previous node is equal to none. Now previous node is equal to current node and node. Okay, so now we have the current node, and then now we want next node is equal to none for this. Yeah, next node is equal to current node dot next. So then we could basically, these are just nodes that are next to the stuff that we want to reverse. In this case, it'll be 1 and 5. So then we could kind of keep track of them later. But yeah, let's reverse the list. Yeah, let's do it with the stack. I'm going to try to do it with the, while length of stack is greater or equal to 2, so that you can look at the top two. Let's do stack of -1, which is the last item on the stack, point that to stack of -2. Okay, and then now we stack that pop right. Is it pop right? Is this pop or pop right? I always forget. Okay, pop does remove the last item. So that's pretty much all we have to do. Now, now we have to go and point the 1 to the last element. So previous node is equal to, previous node.next is equal to the current, so the last item. No, yeah, the last item. So it should be the only thing that's on the stack, the one item left. And then the next, we want something to point to the next node, which is the 2 to the 5. And then it's actually the first. Oh, wait, no, this way. Maybe I mixed this up a little bit, actually. Because the last item to be popped, now it will be 3 pointing to 2. So yeah, so this is right. But now we want the 2 to point to 5, which is the first item that comes here. So then the previous node. Okay, so then now previous node dot. So previous old next dot next is your next node. I think that's it. It's a little bit weird. Let's give it a go. Oops. I don't know what we're supposed to return. It doesn't tell me really. Okay, maybe just the head node. Okay. And we have to do some checking with you reverse the first node and stuff like that. But I just want to get something right. Okay, let's just return head, and then that should at least kind of see where it goes for us. Okay, well, that didn't go well. Or the head node, or the what is the previous node? Let's just double check. There's a lot of edge cases with these ones. That's why it's always tricky, and I'm very aware of how scary this is. So 1 points to 2. So previous nodes next should be. What is? Oh no. Oh yeah, this is wrong. I knew that this was going to be wrong. I keep on confusing it. But we want the first item popped. So let's just do first node is equal to none, and then. Yeah, first node is equal to current node. This is a lot. This is a mess of sorts. Wait. Now the first node should be the 4 node. Right? Nope. Okay. Oh no. Whoops. No, should be right. Why is the? Oh no. Whoops. This should be here. A little confused. Okay, there we go. But this is not done because there's stuff like 1, 2, 3, 4, 5. You want to reverse the entire list. Let's reverse a subset of the entire list, but start from the beginning and then again, but from the end. Let's try that. I'm pretty sure this is not right because we didn't handle any of those cases. I may even get a error-ish thing. Yeah, okay. And then now we have to check if previous node is none, that means it's our head. Then head is you go to next node, else, I guess do this. And but then we have to do do we have to do the last node? It's a little slow right now, but it says everyone is on the server for whatever reason. Refresh the page. Oh no, but then my test cases, I have to type it in again. Okay, fine. Okay. So yeah, as I suspected, we definitely have something wrong, which is we're not handling the first node correctly. All right, so let's break down the cases. If the previous node is none, that means the first, if the previous node is none, that means that M is the first case. So now we want head to be the last node. So that's going to be next node. But however, no, we want that to be the first node. Sorry, that's why. And then see if that's good enough. Found cycle on the linked list. Okay, well, what? Is that my output? That's not my output. My output and cycle on this node. I mean, I guess that could be right, but or that could be an interpretation. But I wish they just print out what I tried to give. So it won't let me print it out because there's a cycle on the linked list, which is fair because then it just goes on forever. Okay. Head is equal to first node, and so we want the head next dot, oops. So we want the previous hex dot next is equal to next node. I think that's it. I thought I was able to kind of have time for this, but now we have to also test one element cases. Okay, I mean it's wrong answer, but that's fine. I'm off by one. That's okay. Or something that we can handle. Because we do not handle if head dot next dot next. Oh, head is already the thing, so maybe that's what I meant. Yeah, okay. But now let's test the one element cases. I think that's what I would worry about. Let's just keep it easy. And also just 2, 2. Yeah, let's try that. Well, into 1, 1 is fine. Expected is 2. Okay. Well, I think we could. There's probably some error handling for n is equal to m case because right now this code assumes that they're not the same. So let's just, to be honest, let's just shortcut this. If m is equal to n, return head. And I think that's probably most okay. Let's just try it. I think there might be still. This is very easy to get wrong. Ooh. Oh, I thought that I did the entire. Oh, these are indexes, not on the value. That's annoying. Okay. I mean, I think I read, but they all the one input did not. But okay, that's easy to fix still. But it's just that well, just that I think I misread the thing. But yeah, let me think about it for a second. Let's just do cat, right? think this is right, but it could be off by 1, so let's try it, honestly. So 1 is the first one. So yeah, okay. Well, let's actually do this in a cleaner way, which is because we want the 0 indexing. Okay, let's try again. Oh, I should have tested that test case first. I think I was a little eager. But yeah, but that's all it is. There's a lot of edge cases. So I think there are a couple of caveats here. One is that if you implement your own linked list, one thing that I would recommend these days is to use the cell node value, so that it kind of wraps around in a way, but so that you don't have to worry about all these things so your head will actually be a nil head. But of course, this is a very special problem where you have to do things in one pass, and you have to do it. Well, I guess technically you don't have to do it in place, but with linked list, a lot of the times that's what they want you to do, because that's the difficulty in an interview. Because otherwise you could just put on a list and then create an entire linked list, right? So that kills the point a little bit. But as a result, there is a lot of weird things about this problem, and you just have to, like, I think in terms of understanding, it's very straightforward, but there's just a lot of edge cases, and you have to figure out what is the best way to handle those edge cases. But I use an explicit stack. Feel free to use a recursion implicit stack, and that's the way I would think about this problem. Yeah, and linked list comes up a lot on interviews, so good luck and good practice, and have fun and all that stuff. Yeah, that's all I have for this problem, and cool. Thank you.